Welcome back to Chapter 10. We're moving on to Chapter 10, and we're going to look at, again, graphs and equations in circles and arc measures in circles. The main topic that we're going to look at today is 10.1b. We're going to use properties of tangents. Just make sure before you go to this section that you look at 10.1a first and know all of the vocabulary that's associated with this section. Let's look at the theorem. You're going to notice in this theorem it says two segments tangent to a circle are congruent. What this means is if I have a line xy and I have a line wy, if they're tangent to that circle, this section and this section are congruent. And that is going to be helpful with the problems that we look at today. We're also going to look at something called inscribed and circumscribed. Inscribed is just that. It's inside. It's the inside shape. So if I look at inscribed on that, it would be the triangle. The triangle is inside the circle. When we look at circumscribed, circumscribed means it's kind of like circumference, but it's the outside. So if I look at the second shape right here, the triangle, again, is what we're going to look at because it's outside. It's the outside shape. So again, inscribed means inside. That would be the triangle. And circumscribed is the triangle on the second shape because it's on the outside. So you're going to notice that the word circumscribed is in this problem. It says, find the perimeter of the following circumscribed polygons. So to do this, what we're going to do, you're going to notice that this line segment right here is 15. This line segment here is 20. And I've got some pieces. I've got a 13, which is the distance from here to here. And I got a 12, which is the distance from here to here. But I'm not sure about this side. I don't quite know how long it is. Okay? So what we're going to do is we're going to use some of what we just learned. I know that this section from here to here is 13, and I know this section from here to here is 12. Okay, so really what I'm looking at is this whole bottom is 25 because 12 plus 13 is 25. But right here, this 12 piece, this is of interest to us. What I can do is I can say this part right here, which is tangent to the circle, and this part up here, which is also tangent to the circle, this is 12. Okay? I know that, let's keep going around. I know that this is 13, and I know this part right here is 13. I need to find the distance here, and to find that distance, I'm going to take 20 minus 13, and that gives me 7. So the distance from here to here is 7. The distance from here to here is 7. And we're going to just keep going around. Okay, I want to find this distance from here to here. Well, if I take 15 and I minus 7, I get 8. And so this is 8. And because I know that's 8, I know this piece right here is also 8. And so if I'm taking a look at the distance all the way around, like what's the perimeter of the trapezoid, what we're going to do is we're going to take a look at all the pieces. So I'm going to start with this 12 right here. And I'm going to go 12 plus 13. Okay, that's this 13. I know this whole side is 20, so I can go plus 20. I know the whole top of this shape is 15. And then I've got an 8, which is here. And I've got my 12, which is here. Okay, so if you take your calculators and you go 12 plus 13 plus 20 plus 15 plus 8 plus 12, I get 80 units. And so that is how the perimeter of the figure on the outside. It's the circumscribed polygon. All right, let's come down here and let's take a look at this figure. So this one is the same type of idea. I'm going to start with my 8 right here. So I know this part is 8, so I know the other part is 8. Okay, I know this top part is 10, so this piece is 10. I know this piece right here is 9, so this piece right here is 9. I know that this piece is 5, so I know this piece right here is 5. 18 minus 5 is 13. So this piece here is 13, and this piece here is 13. So we kind of go all the way around to try to find it. And I needed to find this 13 so that I could find the measure of this, which is 13. So to go around now and try to figure out how much, I'm going to start with, let's start with the 5 right here. Okay, so I'm going to take 5 plus 8 plus 8 plus 10 plus 10 plus 9 plus 9 plus 13 plus 18. Okay, so we're going to go ahead and take our calculators. And I end up with 90 units. Okay, that's going all the way around the figure. All right, so now let's go on to the final 2 problems of this section. It says, this is a regular hexagon and they want me to find x. So what we're going to do on these types of problems is we're going to use the radii. You're going to notice there's one radius that goes from here to here, one that goes from here to here, and you're going to notice that it's not the radius from the center to the outside like this. It's not even the center to this. It's the center from this to where the circle and the hexagon touch. So that's really important. So if I'm looking at the radii, it's from the center out, center out, center out, center out, center out, and center out. So it's going from the center to the edge of the circle, but the edge of the circle and the edge of the hexagon have to touch. And so you're going to notice that there's several of these angles in there, and they're all the same. In fact, if I take a look at it, there's 6. And if you remember back from elementary school, there's 360 degrees in any circle. So to solve this problem, what I'm going to do is I'm going to take 360 degrees, I'm going to divide it by 6 because there's 6 little pieces of the pie. And so x is 36 degrees. And that's going to come in really handy when we go to our next sections. And now finally the last problem. What I need to do is they want me to find x. Now one thing to kind of notice on this problem, first of all, notice that I have a tangent line that comes here and it touches the radius. And when it does that, I have 90-degree angles. So you're going to notice there's a 90-degree angle here and a 90-degree angle here. Also notice that this shape right here, there's 1 side, 2 sides, 3 sides, 4 sides. There's a 4-sided shape. And so if you remember, we use the formula n minus 2 times 180. There's 4 sides times 2 times 180. So 2 times 180 gives me 360 degrees. So there's 360 degrees in a quadrilateral. Well, because I know that now, and I know that this is 90 degrees and this is 90 degrees, what I'm going to do is I'm going to take x plus 90 plus 90 plus 152, and that's going to give me 360 degrees. So I've got x plus, go ahead then and grab your calculators. I got 332. Subtract 332 from 360. And x equals 28 degrees. And that is it for today. If there's any questions, please feel free to let me know, and I'll see you soon.